Hello students, very good afternoon all of you. Good, I hope everyone is enjoying your life and enjoying your JNV life. Okay, we are live now. So just let us wait for our YouTube friends. They will join and we will start our class. Yeah, it's almost 3 o'clock. We will start our class. So we are studying about organic chemistry, the basic principles of organic chemistry. In the last class, we have studied about the history of organic chemistry, how different organic compounds are synthesized in the laboratory, right? So today, we will move one more step upwards and we will solve some of the previous year questions. Good. So before that, I'm launching the technical check. If everything is fine, let me know that. So I have launched the technical check. If there is any issues, you have to let me know. We will solve that and we'll move forward. Okay, so I launched a technical poll. You can give me the responses. Okay, I'm getting the response. I hope everything is fine now. So I'm ending the poll here. Okay, good. So before starting today's topic, so this is just a memory test for you. So last day we have discussed so many things about organic compounds. Then we have discussed history of organic compounds. So this is just to test your memory. No one will ask these kind of questions in entrance examination. There is only very less chance. So first read the question, then after that you have to tell me the correct answer. In the YouTube live chat, you can give me the correct answer. So which of the following scientists propose that a vital force, there is a mysterious vital force present, right? But responsible for the formation of organic compound. Who is a scientist? Is it Berzelius, Wohler, Berthelot, or Kolb? So the correct answer, it is given in NCERT. So Berzelius. So Mr. Berzelius proposed vital force theory. So he has proposed vital force theory. Done. Then one more question to test your memory. Okay. So which of the following organic compound was synthesized by Wohler from an inorganic compound? I hope you remember the points. So which organic compound was first synthesized in the lab? So what is the correct answer here? So we have methane, urea, acetic acid, chloroform. So what is the correct answer? So urea is the first organic compound synthesized in the laboratory. Who synthesized that? That is our Wohler. Then methane. Methane was first synthesized by whom? So methane synthesized by Berthelot. So Berthelot synthesized methane. Then acetic acid. Acetic acid is first synthesized in the laboratory by whom? So that is our Kolb. So these are the points given in your NCERT. Then chloroform. You may be very much interested in chloroform. In movies, you have seen that chloroform. So what is the use of chloroform? There are so many uses. You might know that chloroform, why we are using chloroform, right? So these are the very simple questions, NCERT textbook based questions. So these are the questions to check your memory or whether you have read the NCERT textbook or not. So whether it is your CBSE exam or entrance exam, NCERT textbook, that is very, very important. Okay. So one homework questions, what is the correct answer for this one? Actually, we have discussed this already. So the state of hybridization of C2, C3, C5, C6 of the hydrocarbon. So what is the correct answer? So C2, triple bond is there, that is sp. Then second one, 1, 2, 3, 4, 4 sigma bonds. So that is sp3. So our correct answer is, so A, that is sp, B, C, D. Then second is sp3. So option D. So this was the homework question for you. So I have given one more homework question for you. So find the total number of pi bond electrons. So can you count the number of pi bonds here? So how many pi bonds are present? That is 1, 2, 3, and 4. So it is not about pi bonds. It is about pi bond electrons. In a pi bond, there are 2 electrons. Total 4 pi bonds. That means total 8 pi bond electrons are present. So the correct option for this NEET previous year question, that is 8, not 4. It's not about pi bond. It's about pi bond electrons. I hope this is also clear to you. So next one, okay, yeah, we have to start today's topic. That is how to represent the organic compounds. There are so many methods to represent the organic compound. So let us study about this representation. We have studied some of the representation in chemical bonding chapter. Okay, so we have structural representation of organic compounds. So first we have to write the structural formula. How to write the structural formula? For example, we have methane, that is CH4, ethane, that is C2, CnH2n plus 2, H6, or C3H8. So formula is given. So we have to represent that organic compound. There are different methods. One is Lewis structure or Lewis dot structure. We are using dots to represent the electrons. We have studied this in which chapter? Do you remember that? That is our chemical bonding chapter, right? Next one, next representation, that is dash structural formula. Dash, or I can say line. We are using line to represent the bond. Then third one, that is condensed structural formula. We cannot always write completely using these Lewis structures or dash structural formula. So we are condensing that. Condensing means we are reducing the structure. Then last one, that is our bond line structural formula. If you are an expert in organic chemistry, you won't write all these things. You will just draw some lines. Then you will say this is decane, this is ethane, methane, like that. So we have to study all these representation of the organic compounds. So let us first study about the first one, that is Lewis dot structures. I hope there is no need to explain much about Lewis dot structure. We have already studied that. Still, let us just recap what are the things that you have studied. So Lewis structure. So in this, a pair of electrons forming a covalent bond is represented by a dot or cross. You can use dot or cross. Clear? So example, carbon. So carbon, it belongs to the 14th group, right? So 14th group, can you tell me how many valence electrons are present? There are 4 valence electrons. That is last digit. 1, 4. 4 is the number of valence electrons. So around this carbon, I'm writing 4 dots. Dots means it is an electron, valence electrons. Okay. Then I want to form methane. So our hydrogen, our dear friend, hydrogen is coming. This carbon and hydrogen, they are like friends, like Ramcharan and India. So they are close friends, right? So this hydrogen is coming. How many electrons this hydrogen has? It has 4 electrons, right? 4 hydrogen, 4 electron. 1 hydrogen, it has only 1 electron, right? So it is forming some bond, carbon hydrogen bond. 2 electrons are present in that bond. So a single covalent bond is formed. So this is dot structure. Then what about cross? Instead of dots, we are using cross. Same thing. So this is a dot structure. Next one is cross structure. So electrons are represented as cross, right? So this is a Lewis dot structure. We have studied how to write the Lewis dot structure for compounds, right? So very simple. Second one, dash structural formula. How to write the dash structural formula? We have studied the dot structure for methane. Then again, methane is coming. So methane is forming, in methane, carbon is forming a single bond with our hydrogen. So we are representing carbon, a dash or a line, hydrogen. There are 4 hydrogen atoms. So carbon is forming 4 single bonds. So I'm drawing 4 lines or 4 dash. If it is a single covalent bond, only 1 line. Single, right? So single line means there are 2 electrons present in that. A pair of electrons I can see. Next, I have a double bond, alkene. So I can say there are double bond present between these carbon atoms. To represent the double bond, in 1 bond, 2 electrons. 2 bonds, there are total 4 electrons. So I'm using a double bond. So I have to use a double line here. Then what about the carbon and hydrogen bond? Single line. So this is the next dash structural formula. Then one more. So we have alkynes. So in the case of alkynes, there is a triple bond present between carbon and carbon. So in order to represent that triple bond, I have to use a triple line. There are 3 lines. So it represents a triple bond between carbon and between carbon and hydrogen. Same. Hydrogen has only 1 electron. So in only a single bond, hydrogen can form with our carbon. Okay. So this is our dash structural formula. First one, Lewis dot. Second one, dash structural formula. So what is the third one? Do you remember the third structural formula, how to represent these organic compounds? So third one, it is important. It is very useful for our studies, right? In order to write the structural formula. So one more example for your dash structural formula. So what is this formaldehyde? So we have studied about functional group, right? So if I have C double bond O H, that is our aldehyde. That is our aldehyde group, right? So this is a free valency. So in this free valency, one hydrogen atom is coming. Then that is known as formaldehyde, right? So this oxygen belongs to 16th group. There are 6 valence electrons. So I can represent one electron is present here, second one. So these electrons are involved in bonding. So what about other electrons? These other electrons are simply resting. They are not doing any job. They are taking rest. So they are known as lone pair electrons. So how many lone pairs are present? There are 2 lone pairs present in formaldehyde. So oxygen has 2 lone pair electrons. Okay, it has 2 lone pair. I can say like that. Then the bond between carbon and hydrogen, that is single bond. Then carbon and oxygen, that is a double bond, right? So this is a representation. Then again, dash structural formula. So we have ethane, right? Then ethene alkene we have. So double bond, so double line. Single bond, single line. Then next we have ethine, triple bond is. So next one, that is, what is this? I can write it as CH3OH. Again, our oxygen, it has lone pair. So how many lone pairs? It has 2 lone pairs present. Or I can avoid this lone pairs also, no issues at all. So I'm removing this lone pairs. You know, you have studied the chemistry. So you know oxygen has some lone pairs present. So C, carbon, hydrogen, single bond. Carbon, oxygen, single bond. Oxygen, hydrogen, again single bond. So this is methanol. So methanol, okay, not ethanol. So methanol, ethane, ethene, ethyl. These are the different representation in our dash structural formula. Again, this is a very simple thing. You have studied all these things in your 10th class itself. We are just giving the name for this different representation. So dash structural formula, that is also done. Then what is next? So do you remember the next one? So next one. So these are also known as complete structural formula. Okay. So next one is our condensed structural formula. So condensed structural formula means, so we are chemistry people, right? So we can't always write all these things. So we are reducing the structure. So we are reducing that. How to do that? So we have single bond between carbon and hydrogen. So in this condensed structural formula, we are not using this single line. So we know already there is a single bond between carbon and hydrogen. So I'm writing one carbon. Hi, hello. So some of our YouTube friends are saying hello, hello. You're from which JNV or which school? Or what is your name? Okay, I'm seeing your chat, live chat. Hello, hello. So ethane is there. So what I have done here? So I have done CH carbon. Then 3 hydrogen atoms. I know single bond is present. Then carbon and carbon, again single bond is present. So this is the next one, that is ethane, right? So one more example. So we have alkenes present. So in the case of alkanes, single bond is present. No need to represent that single line. We know that already. So what about double bond? So we have to show this double bond in condensed structural formula also. So how to represent carbon and hydrogen? They have single bond. No need to represent that. So CH2. Then carbon-carbon double bond is present. So I have to draw a double line. So double covalent bond. So CH2, CH2, that is ethene. That is a condensed structural formula. Then one more example. We have alkynes. So our alkyne is present here. So our alkyne is present here. So again, single bond, no need to represent the single bond. So I can write CH. Then triple bond is present between carbon and carbon. Then last one more hydrogen atom you have to add. So this is a one more condensed structural formula. Then our dear methanol. So methanol, carbon and hydrogen, there are single bond. So no need to represent. So we can write CH3, then carbon, oxygen again. Okay, good. Homework is done. Okay, I'm happy. So you're working. Okay, you have to work harder, then no one can beat you. It's good. So today also I will give you some more questions. You have to practice that. So I mentioned the correct answers for that. So last class you have made some mistakes. It's okay. We are learning. So you have to make the mistakes and learn the things. So we have methanol present here. This is a condensed structural formula for our methanol. Okay. So we are condensing, we are reducing the structural formula. Okay. So next one, we have already condensed. Again, we are condensing. So I have octane present here. So this is terminal carbon atom. This is also terminal carbon atom. So CH3 group, CH3 group is present. In between, there are so many CH2 groups. It is very difficult to write all these CH2 groups. Instead of that, I'm counting the number of CH2 groups. So you can also count 1, 2, 3, 4, 5, 6. There are 6 CH2 groups. So I can write it as, I'm condensing the formula, CH3, terminal position. Next CH3, the terminal position. In between, there are 6 CH2 groups. So write a CH2, then parenthesis or bracket, then 6. So it means that there are CH2, 6 CH2 groups in between our terminal CH3 and CH3, right? So that is again condensed formula. Then one more example for you. So we have 4,5-dimethyl hexanol. Why it is named as 4,5? We are studying about IUPAC nomenclature, right? So here, first carbon, OH is our functional group. Then second one, third one, fourth one. Then this is fifth. This is our sixth one. So 6 carbon atom hex, right? OH is a functional group, O. So, or I can write it as like this, CH2, then I have OH, then again CH2, CH2, then CH. This CH is the branch, CH3, that is a branch. Then one more CH, then again a branch. In parenthesis means it is a branch, substituent. So next CH3, okay. So here, check it. So how to reduce a structure? So I can write it as, I'm condensing the structure. So I have OH, then here 1, 2, 3. So 3 CH2 groups. So write a CH2, then bracket 3. That means there are 3 CH2 groups present. Then next we have a CH, then there is a CH3 branch. So that is represented inside a bracket. Then again our next CH group, then again bracket. So we have attached to, we have 2 CH3 groups attached to this carbon. So I can write CH3 twice. That is, we are condensing the formula again. So first one is octane, second one is 4,5-dimethyl hexanol. So why the name? We will discuss about that. So there are 6 carbon atom. OH is a functional group. That is all. Then in the fourth and fifth carbon atom, one CH3 group, one branch is present. That is why dimethyl. There are 2 methyl groups as branch. So 4,5-dimethyl. I hope it is clear to you. Hello, student. So next one, Pindu Kumar, welcome to the class. Then we have bond line structural formula. So we are chemists, right? So no need to write all these things. Just like a zigzag line, we can draw the organic compounds. How to do that? So carbon and hydrogen are not shown. So no need to separately write carbon and hydrogen. They are represented by line. Then we are going to draw some zigzag lines. How to draw that? Okay, so we have 3-methyl octane present here. So 3-methyl, that means 3-methyl means in first, second, third carbon, there is a substituent or a branch, that is CH3, that is our methyl group. Then how many carbon atoms are present? 4, 5, 6, 7, 8. That means octane. There are no double bond or triple bond, only single bonds are present. So 3-methyl octane we have. How to represent that? So this is our first carbon, second, third one, there is a CH3 group. Then we have 4th, 5th, 6th, 7th, and 8th. Okay. So again, we can condense that. So how to do that? Just draw zigzag lines. So actually, we have to understand that in this terminal position, there is a CH3 group. In this terminal position, there is a CH3 group. I will show you. So these are the terminal positions, right? So terminal represent methyl group. What is this methyl group? That is our CH3. CH3 is present at the terminal position, right? So this is our zigzag representation, or I can say bond line structural formula. We are not writing carbon, we are not writing hydrogen, we are just drawing lines. Okay, I hope it is clear to you, this one. Great. So next one, we have to, yeah, good. Okay, it's clear. Nice, nice, nice. Bond line structural formula, carbon and hydrogen we are not representing, but some other atoms, if oxygen, chlorine, nitrogen, some other halogens are coming. So how can we identify that? So in bond line structural formula, carbon and hydrogen, we can represent it by lines, but some other atoms are coming, then we have to show that. Otherwise, we can understand, right? So 2-bromobutane. 2-bromobutanes mean there is one bromine, Br is present. So how to represent that? So this is CH3. So first carbon, second carbon. The second carbon, there is bromine, Br attached. Then this is our third one. This is our fourth one. Okay. So just a second. Okay, great. So second position, there is a bromine. So again, I can draw the bond line structures. So CH3, CH, I think pin 2 is doing this, right? Some lines I can see here. Okay, remove that. So CH3, CH, CH2, CH3. So first, second one, second carbon, there is bromine present. Okay, so I can represent like a zigzag manner. Zigzag lines are present. But in the second carbon, you have to mention a bromine atoms. Otherwise, I can't understand that a bromine is present. If oxygen, chlorine, bromine, etc. present, you have to show that. If carbon, hydrogen, no need to show that. This is our bond line structural formula. Okay, right? So in cyclic compounds, what is a cyclic? A closed chain. Okay, they are cycling ring compounds. So I have cyclopropane. So what is the formula for that? How many carbon atoms? That is C3. How many hydrogen atoms? We have H, 2, 4, 6. C3H6. So can you tell me C3H6? So what about alkenes? Alkene with 3 carbon atoms. So what is the formula for that alkene? So 3 means prop. So what about propene? What is the formula for propene? So that's a homework for you. So you have to tell me the answer in the chat box. So what is the formula for propene? There is a double bond present, alkene. Okay, CnH2n plus 2. CnH2n, CnH2n minus 2. You have studied alkanes, alkenes, and alkynes. So here we have cyclopropane. So what is bond line structural formula? So no need to represent carbon and hydrogen. Just you have to draw the lines. You have to understand carbon and hydrogen is present. So this is just a triangle. So that is a representation. So next one, we have cyclopentane. So cyclo. Then how many carbon atoms? So 1, 2, 3, 4, 5. So pentane, cyclopentane, that is the name. So how to represent that? So again, so no need to write carbon and hydrogen, just draw a cyclopentane. That's it. Then chlorocyclohexane, chlorine is coming. If chlorine is coming, I can't understand. So you have to represent chlorine there. So this position, one chlorine is present. So you can draw cyclohexane. Then after that, you have to write or draw chlorine here. Then only it is complete. Then only I can understand a chlorine is also present there. Good. I hope it is going good. You're understanding the points. So very basic things, how to represent the organic compounds. There are different methods. We are studying all these things. So we have to start from the basic things, then only advance, right? So next one, in 3-dimensional manner, solar 3D, right? So 3D movies are coming. Your Avatar 3D movie, right? So 3-dimensional representation of organic molecules. How to do that? So we have our simplest molecule. What is that? CH4. That is our methane. So 3D structure. So carbon and hydrogen. There are 4 hydrogen atoms. Then carbon is forming single bond with this hydrogen, right? So these bonds, this bond and this bond, it is present in the plane. Then what about these lines? Dashed wedge is present. Dash wedge means this bond is moving away from the observer. I am the observer. So it is going away from me, right? Then this one, Solid wedge, that means that bond is coming towards me. We have studied Doppler effect also. The train is going away. It is coming towards us, right? So similarly in chemistry also, somewhat Doppler effect. So dashed wedge, away, solid wedge, it is coming towards me. Okay, I hope it is clear to you. If it is clear up to this, the basic things, give me some thumbs up or something, something, participants. Okay, good. I'm getting response in YouTube. Okay, my audio was muted, right? Okay. Sorry for that. Sorry for that. You should have mentioned that. Okay, good. I hope now it is okay. Now it is okay for you. Anna, right? Yeah, someone raised the hand. Good. So I think from this portion onwards, right? So International Union of Pure and Applied Chemistry, there are certain rules. We have to obey those rules, right? Then the name, I'm giving a name. You have to tell me the structure. So IUPAC system of nomenclature. A systematic name of an organic compound is derived. Okay. So how can we name these organic compounds? So some carbon and hydrogen is present. So carbon and hydrogen, we can call it as hydrocarbon. There is a certain chapter for this hydrocarbon. So this is known as a parent chain. Then we have OH group, that is a functional group. Then Cl, that is also a functional group. Then our CH3 is present here, methyl group, right? So that is a substituent or a branch present here. So we have to identify the parent chain. If some branches are present, we have to identify that. If certain functional groups are present, we have to identify that also. So these are our functional groups. So compounds containing carbon and hydrogen, it is known as our hydrocarbons. We will study about this hydrocarbon later. There is a separate chapter for our hydrocarbons. Then what about the saturated compounds? Saturated means there is only single bond present in the compound. Only single bonds are present. If some multiple bonds means that is double bond. It can be triple bond also. Then we will call it as unsaturated. Okay, so that is our unsaturated. So saturated, single bond. Unsaturated, it can be double or triple bonds. I hope that is a very simple thing, right? The saturated and unsaturated. Okay, then we have studied homologous series also. Certain functional groups are present. Consecutive members differ by CH2 group. That is homologous series. Yesterday we have discussed a homologous series, alkanes, then some alcohols also. Then how to name an organic compound. So it is like our Virat Kohli. So we have Mr. Virat Kohli. What is his name? Virat. We will call him Kohli also, right? So this term, salutation, Mr. So it is written just before Virat. So this Kohli, that is after this Virat. The real name is Virat, right? So Mr. Similarly, in organic chemistry, there is word root, that is Virat. Then before that, we are writing something that is known as prefix before pre. Okay, so that is our prefix. Then after the name, there is something. So that something is known as our suffix. Okay, then there is two types of prefix. One is secondary. This is a secondary prefix. This is our secondary prefix. What about pri? Pri means a primary. This is our primary prefix. Okay. Then pri suffix means it is primary suffix. Sec suffix means it is secondary suffix. Right. So what is this secondary prefix, primary prefix, word root, etc.? So let us see that. So word root means so number of carbon atom in the parent chain. So you have to find the parent chain, then you have to count the number of carbon atom. This word root indicates a number of carbon atom. Then what about the primary suffix? We have studied unsaturation or saturation. So N, that means single bond. Then if double bond is present, we have to use E. If triple bond is present, we have to use YNE. So single bond, primary suffix, N is used. Double bond, N is used. Then triple bond, IN is used. So that is primary suffix. Sir, what about the next one? Secondary suffix. Secondary suffix indicates the main functional group. Suppose OH is coming. So what will we call it? OH is the functional group. What is the name of our organic compound? So we have to study about that. Then primary prefix, cyclic compounds or cyclo, we have studied. If some cyclic compounds are present, then we have to use the primary prefix as cyclo. Sir, if there are no cyclic compounds, what should we do? So no need to write cyclo, right? Then secondary prefix, we have seen some branch or substituent. For example, CH3 was a branch. So if substituents are present, that should be written first, secondary prefix. If some cyclic compounds are present, that is written second, primary prefix. So look at here, this primary, and this primary. It is close to our word root. So prefix, suffix, primary prefix, primary suffix. In between that, word root, it's like a sandwich. Okay, so this is a rule for naming organic compounds, IUPAC system of nomenclature. Okay, Mr. Virat Kohli. So Mr. that is prefix, Virat that is a word root. Then primary or suffix, that is our Kohli. So maybe some Telugu people or Kerala people, they might have a long name. So we can say one is secondary prefix, one is primary prefix, then their name. Then after that, some other father's name can be used like that. So same in a same manner, we are naming the organic compounds also. Okay. So we have to find the root word. So root word means we have to find the number of carbon atoms. You know this. If only one carbon atom is present, meth is a root word used. 2, eth, 3, prop, 4, but, 5, pen, 6, hex. So what about 7? So 7, we can write it as 7. That is known as hept. Okay, then what about 8? That is oct. What about 9? That is known as not. What about 10? 10, that is our deck. There are so many examples, undeck, dodeck, etc. So we need up to minimum up to 10. If the number of carbon atom, if it is 10, we will use the word root deck. Okay, I hope it is clear to you. Then alkane. So in alkane, so we have, in this alkane, we have 2 carbon atom. 2 carbon atom means what is the word root present here? That is eth. Then what about the bond present? Is it double bond, single bond, or triple bond? It is simply a single bond. So we can use A. 2 carbon atom, eth. Then A is coming. So just join these two words. So what is the name of this one? That is ethane. Okay. Then second one, we have an alkene. Again, two carbon atoms are present. What about the bond between this carbon atom? There is a double bond present, right? So double bond present means we have to use ene. So ethene is the name of this alkene. There are two carbon atoms. Then third one, alkynes are present. Alkynes means there are three bonds, triple bonds are present. So C, triple bond C. Then what about the number of carbon atom? Again, two. So same word root, that is eth is used here also. Then someone is coming and we have to join these two words. That is triple bond is present. The name is ethyl. So this is alkane, alkene, alkyne. There are no functional group present here. Only single, double, triple bonds present. You have to count the number of carbon atoms. So yeah, good, ethyl. Yeah, that is correct. So I'm getting response from you two friends. Great. So you have to respond. You have to practice. This is like your mathematics. You have to practice, practice, practice. So you have to practice your skills like Lionel Messi. Then only you can improve. Last day, so I saw some photos, these students attending in Apple class. I saw some Lionel Messi, Cristiano Ronaldo in my class. So some were wearing this jersey and attending the online class. So even Lionel Messi fans are attending the online class. It's great. You will be also a world champion one day, but you have to practice. So IUPAC nomenclature. So we are coming back. Okay, leave Lionel Messi. We are coming back to nomenclature, naming process. So we have straight chain hydrocarbons. How to name this straight chain hydrocarbon? Okay, so if there is a single bond, it will end with A. So names of such compounds are based on their chain structure. It ends with a suffix A. Okay, so methane, formula CH4. Then ethane, C2H6, only single bond is present. So we can say there are two carbon atoms, eth. Then ane, that is single bond is present. Then C20, there are 20 carbon atoms. That means icosane. So no need to by heart this one. We need only up to 10 or maximum 12. Nonane, then decane, then triaconane is also present. So we don't need that. Okay. In NCRT, it is given. The table is given. That's it. Then nomenclature. So parent chain, you have to identify the parent chain. Then small chains of carbon atoms are attached to this parent chain. Those small chains of carbon atoms are known as branches. Okay, there are different branches present here. So here you can see first carbon, second carbon. In the second carbon, there is a small chain of carbon atom. Here only one carbon is present. So this is a branch. Then here you can see 1, 2. Here also another carbon atom with a branch. So this branch, we will discuss the name of this branch. Then this is our methyl groups. So small carbon chains are called alkyl groups. So what is this alkyl groups? We know alkane. So what is the alkyl group? Can you tell me? What does this mean? Alkyl groups. So let us take a methyl. How can we form a methyl group from a methyl? So just take methane. Then you're good people, right? You're giving some money to someone. So money means hydrogen. So you're giving one hydrogen atom to someone. So just break this bond. I'm removing one hydrogen atom. I'm donating one hydrogen to Pindu Kumar. Okay. Then what is remaining? So I have C. There are 3 single bonds between carbon and hydrogen. Then fourth valency of carbon, that is vacant. So that is known as methyl group. This vacant valency will attach to some parent chain. Then a branch is formed, right? Yeah, great. So branch chain hydrocarbons. So from methane, I'm removing one hydrogen atom, methyl group is formed. Similarly, from methane, I can remove one hydrogen atom. What is formed? That is ethyl. So here you have the representation: propane, propane, butane, butyl. Just remove one hydrogen atom. Then decane, decyl is formed. That is 10 carbon atoms are present, 22 hydrogen. So from that I'm removing hydrogen, decyl is formed. Okay. So these alkyl groups will form branches. In our parent chain is present, some branches will be formed. So these alkyl groups will form some branches in our parent chain. So you know about this. We have already discussed all this, right? So I hope we can move forward. We will, Jen, we Kadapa students, we are good. So branch chain hydrocarbons. So alkyl groups can be branched also. So I have propane. So I have simple propane, that is CH3, CH2, CH3. Okay. If I remove one hydrogen atom, I will get CH3, CH2, CH2, then a free valency. So this is known as normal propane. There is no branches, straight line. So that is known as normal propane. Then again from this carbon, I am removing one hydrogen atom. So one free valence will be formed there. So I will get isopropane. Iso means same or similar. That means this CH3 and this CH3, that is similar. So I can write it as CH3 two times, then CH, one free valence is present. This free valence will attach to the parent sheet. So that is what is going to happen, right? So we have secondary butyl. Then butyl means there are 4 carbon atoms. Then we are removing one hydrogen atom from there. Then after that, we have isobutyl, or I can write it as CH3 twice, CH, then CH2, a free valency. That is our isobutyl. Next, we have tertiary butyl. So this carbon. So what is the degree of this carbon? So degree means this carbon is attached to one carbon atom, two carbon atom, third one. So this is a tertiary carbon. If one carbon atom is attached to 3 other carbon atom, we can call it as tertiary. So this is known as why butyl? 1, 2, 3, 4. There are 4 carbon atoms present. So we can call it as butyl, tertiary butyl group. Then we have neopentyl. Pentyl means 1, 2, 3, 4, 5. There are 5 carbon atoms. So pentyl, from pentane, pentyl is formed. So we can also write normal pentyl. So that you can do it. Okay. So this is isopropyl, secondary butyl, isobutyl, tertiary butyl, and neopentyl. These are different branches, different alkyl groups. So you have to remember this: isopropyl, secondary butyl, these 3. Okay. So if it is clear, then we will go for a previous year question. So are you ready for the previous year question? So let us go for the previous year question. This is NEET 2013 question. So can you tell me the answer? So what is the answer? The structure of isobutyl group in an organic compound is. So what is the answer for this one? So what is the answer for this one? Can you tell me? The structure of isobutyl group in an organic compound is. So we have studied this is normal butyl. So normal butyl, right? So this is. So what is the name? So tertiary carbon. So tertiary butyl. I can say tertiary butyl. So what about this one? So what is the name of this one? You have to tell me. So what about this one? This carbon is attached to 2 other carbon atoms. So I can say secondary butyl. Yeah, I'm getting answers in the YouTube. Yeah, good. So the correct option for this question, that is our C option. So I can also write it as CH3 twice, then CH, then CH2, then single bond. So that is the correct option. This is NEET 2013. Okay, so we will end it here. So we have discussed a previous year question. We have studied some very basic things. You have to practice that. Then in the next class, we have to study this, what is isobutyl, tertiary butyl, secondary butyl. Then only we can move forward. Okay, so I hope you understood the points. We will stop it here. In the next class, that is tomorrow, we will meet again. We will discuss some more questions. We will discuss some more concept. Okay, so JNV Kadapa students, we can end it here. Okay, participants, bye-bye. We will see you in the next class. Yeah, YouTube friends, bye. We will see tomorrow. So we will study about some more IUPAC nomenclature rules. Okay, so that's it. I am stopping the video. So we will meet again. Bye-bye, students. Okay, JNV Sadara, JNV Kadapa, then Samsung. Okay, then bye-bye. Okay, tomorrow I will give you some homework question. Today there are no homework question. We have studied